Hello everybody and welcome to Algebra 2. Today we're going to be talking about 1-5 solving inequalities. Let's get started. So, very first thing that we need to know is, well, what's an inequality? If an equation always has to have an equal sign, then an inequality must be something that doesn't show an equal sign, right? So if I were to take a look at the very first one, you have 15 is greater than that 32x. Again, remember, the less than spells out less than. And the greater than kind of creates a G in a way, and it spells out greater than. It's a little bit of a stretch, but it gets the job done in my eyes. All right. So for this one, we have 15 is greater than 32x. That is not an equal sign in the middle, therefore this is going to be an inequality. Once again, this 45 is less than 46, and that is not an equal sign, and therefore is an inequality. But this is a tricky one, because this has equal in it. Like, this is negative 27 is not equal to 3x. Well, if it's not equal, it's still not an equal sign, literally, and therefore is considered an inequality. But the last one, however, is an equal sign, which means we know that we're talking about an equation right here. Can you complete each statement with less than, greater than, or equal to? Is 9 over 2 less than, greater than, or equal to 4? Well, 9 over 2 is 4.5. 4.5 is greater than 4, so 9 over 2 should be greater than 4. 2 plus 3 gives you that 5. You have to multiply out that 5 with the other 5, giving you a total of 25. And is 25 less than, greater than, or equal to 27? Less than. 0.6 repeated is the exact same thing as 2/3. 2/3 is just going to become 0.6 repeated, which means this answer should be equal. And last but not least, is negative 6 less than, greater than, or equal to 4? That's right, left sign. A student uses the word compound in 3 different sentences. Can you place a check mark next to the sentences that use the word correctly and place an X next to those that do not? Well, in chemistry class, we learn about various chemical compounds. I don't know about any chemistry class that you've been in, but that sure sounds pretty accurate to me. Now, compound inequalities contain more than one inequality symbol. I'm here to tell you that that is 100% true. That would be a question that looks kind of like a 2 is less than an x, which is less than 4. That is a compound inequality. And last but not least, to simplify an expression, you can compound like terms. That doesn't sound right. I think it's supposed to say combine like terms, so I'll put an X on this one. Now, write an inequality for each verbal description. X is at most 25. This is a little bit of a tricky one, because at most, you immediately start to think more. But at most is not considered more than. All right. In fact, it's the opposite. It's saying that no matter what, we can't go past that 25. That 25 is our limit. And therefore, X is at most 25 is going to become X is less than that 25. However, we can also include that 25. So it really becomes X is at most, or X is less than or equal to that 25. X is not equal to 25. Well, like we did in the previous question earlier, we found out that not equal is also an inequality, but you also show it by saying X, and you put an equal sign, but the not portion comes from this slash mark that you put through it. So you have X is not equal to 25. X is greater than 25. You'll have X and then a greater than sign. The greater than sign, remember, is going to be kind of the ending portion to the G. So it's going to be X is greater than 25. And last but not least, the X is less than 25 is going to be virtually the same exact thing as you saw in question 9, only the opposite direction. The thing that looks like the L will be what we plug in. So it's X is less than that 25. What inequality represents the sentence, the quotient of a number and 3 is no more than 15. What does the quotient of a number and 3 represent? Well, if it's the quotient, we know it's the answer of a number divided by 3. So the only one that shows a number n divided by 3 will be the n over 3. The symbol what represents the phrase no more than. No more than means that it can't be greater than. So we know that it can't be this one. We also know it can't be this one. Now it's either less than or less than or equal to. Well, if it says no more than, it means that we can actually get all the way up to that 15. We could even touch that 15. We could use that 15, and that phrase will still be correct. And since that is a case, that we know that it's actually going to be the less than or equal to. Now, how would you go about writing this down? Well, n over 3 is less than or equal to the number that we're talking about, so for 15. So n over 3 is less than or equal to that 15. What about trying to figure out the solution to an inequality? Well, in order for you to solve an inequality, you have to work it out the same exact way you would an equation. There are a couple little bit of rules here and there that we'll run into, and I think we will for this problem especially. But for the most part, you just solve it the way you normally would. So I'm going to rewrite it out as negative 2 times the x plus 9 plus 5 is greater than or equal to that 3. You can distribute out that negative. It's perfectly fine. You're absolutely able to do that. Or, since we're going to be multiplying that negative 2 times the x, and we're eventually going to have to move everything away from the x anyway, I'm just going to keep that there until we get everything away from the set of parentheses. So that plus 5, I'm going to move. I'm going to subtract 5 from everything first. Now we're looking at negative 2 times the x plus 9 is going to be greater than or equal to 3 minus 5, which is negative 2. Now I'm going to divide everything by that negative 2. The reason you do that is because it will actually eliminate the parentheses altogether. So I'm going to divide both sides by negative 2. And this is where the one problem comes in. When you divide by a negative, you need to make sure that you flip the sign. So what originally was a greater than or equal to sign now will become a less than or equal to sign. So I'm going to be left with everything that's down to the negative 2. So we have the x plus 9. But again, instead of it being a greater than, the dividing by negative means that we're going to flip the sign, making it a less than or equal to sign. Negative 2 divided by negative 2 cancels out, but that means that you're going to be left with a 1 because any number divided by itself is always going to equal 1. Last but not least, subtract the 9 to both sides, and you'll get x is going to be less than or equal to that negative 8. So we need to underline the correct word or number to complete each sentence. Well, the graph indicates all numbers, we said less than, so it's going to be less than that negative 8. Because again, x is less than negative 8. However, the graph will also include a closed dot or a closed circle at the negative 8. Why is that? Because of the equal to portion. So if I have a less than or a greater than, it's an open circle. That will create the open circle. All right? And it'll be an arrow that goes to the left or an arrow that goes to the right. But more importantly, it's going to start off with an open circle. If I have less than or equal to, or I have a greater than or equal to, that's when you get the closed circle, because you're including that number, and you'll see that arrow go left or to the right. Okay? So for this case, it's equal to, therefore it's a closed, which means we're including that negative 8. So if I had to graph it, I'm going to go to the negative 8. I'm going to put a closed circle, or a closed dot, and then I have to go less than negative 8. Negative 7, negative 6, negative 5, and on up are not less than, so less than needs to go to the left, because all of the numbers that are less than negative 8 will be going to the left. A digital music service offers 2 subscription plans. The first has a $9 membership fee and charges $1 per download. So I'm going to make sure I understand those two. So we have a $9 fee and charges $1 per download. The next one is a $25 membership fee and charges 50 cents per download. What we're trying to figure out is how many songs must you download for the second plan to finally cost less than the first plan. We're going to pick R, be the number of songs downloaded. All right, and they're going to also say that let C sub 1 equal the cost of the first plan, and C sub 2 is going to be the cost of the second plan. Can we write the algebraic expression to describe the cost of the first and then the cost of the second plan? Well, the first plan starts with $9 as a fee. That is a one-time cost, so I'm going to write that one time. However, then it has something per download. You have to spend money per download. That's going to be the reoccurring thing. The reoccurring amount is going to be what we multiply by the variable, that R, the number of songs. So we have plus 1 because it's $1 per download. So we got 1R. The second plan will end up being the original of that first fee amount, which is $25, plus 0.5 or 50 cents per download. So it would be 0.5 times R. Can we solve the inequality? Again, you solve the inequality the same way that you would solve a normal equation, but first we need to make sure that we can actually create that inequality. So how many songs must you download for the second plan to cost less than the first plan? So the second plan, C of 2, needs to cost less than the first plan. So now that we know that, we can plug in what we know C sub 2 is equal to, which is the 25 plus 0.5R, and we know what C sub 1 is, which is a 9 plus 1R. So this will be 25 plus 0.5R is going to be less than that 9 plus R. And I'm just going to write R because it's 1R. So for me personally, I'm going to start with the variables. I need them to be on the exact same side. In order for me to move the variables to the correct side, I always choose the smaller amount first and move it to the other side because that keeps the variables positive. So if we have a 0.5R, 0.5 is smaller than 1, therefore I'm going to actually subtract the 0.5R to the other side, 0.5R over here. This cancels this one out, and we're left with a 25 is going to be less than 9, and then R minus 0.5 gives you a plus 0.5R. The next step, I'm going to subtract 9 from both sides. I'm starting to work towards getting the R by itself. So 25 minus 9 will give you a total of 16. And that would be 16 is less than 0.5R. We are then going to say that 0.5R, we need to move that 0.5 over. So you can divide by 0.5, but personally, I know that 0.5R is the same thing as 1/2 R, which is the same thing as R over 2. So for me, I'm going to multiply both sides by 2. So 2 times 16 will give you that 32, which is still going to be less than the R. If I were to take that 32 and plug it into the R, let's see what we get. So I'm going to base it off of the original thing. The C sub 2 is less than C sub 1. So I'm going to have 25 plus a 0.5 times a 32 has to be less than the 9 plus 1 times 32. So I'm just going to write 9 plus 32. So to simplify it, 25 plus, in this case it will be 16, has to be less than 9 plus 32, which 9 plus 32 is 41. Not 25 plus 16 is also 41. So 41 is going to be less than 41. Right here, this doesn't make any sense. but it's on the cusp. It's just about to be accurate 100%. So for me, I'm going to say in order for C sub 2 to be actually less than C sub 1, I'm going to have to download one more song than the 32 that we're given, because 32 gets it so that they're equal. That one more song will put us over the top, which is going to be a total of 33 songs. Now we have to determine whether or not this statement, this inequality, is always, sometimes, or never true. Well, let's complete the solution. Let's solve it out, right? So we are going to write the original inequality right here. I'm going to use the distributive property, so I'm going to multiply everything out that I see, get rid of the parentheses as soon as possible, and you'll get 8x minus 12 is going to be less than 8x plus 8. They subtracted 8 from both sides, so I'm going to go minus 8, giving us 8x minus 20, and since we're subtracting 8, those 8's cancel out, is going to be less than that 8x. Then they subtracted the 8x. When they did that, they got the statement, negative 20 is less than 0. No matter what you say, no matter what you do, negative 20 will in fact always be less than 0. And therefore, the inequality is always true. Can you describe the solution set of the inequality? Well, since it's always true, that means no matter what number we plug into the x, the value that comes out will always be true. So we're going to call that not no solution, but we're going to say all real solutions, because no matter what real number we plug in, it's guaranteed to be an accurate statement. And therefore, like I said, the set will be of all real numbers. What is the value of 8, which is less than or equal to 3x minus 1, and 2x is less than 12? And can we graph the solution? Well, solve it out just like a normal equation. 8 is less than or equal to a 3x minus 1. We are going to add 1, add 1. 9 is less than or equal to 3x. And then we're going to divide both sides by that 3. And I'll rewrite it up here. So we'll get 9 divided by 3, which is 3, is less than or equal to x. Now, sometimes it's okay to write it like this. Other time people want to put the variable first because it makes it a little bit easier. So 3 is less than or equal to x is the same thing as x is greater than or equal to 3. I'll put a little or symbol. So it's either this or that. Both of those are correct. All right. But notice the sign pointed to the 3. It continued to point to the 3. That's how I know I did it correct. You have to flip the entire thing. All right. So if I were to graph that one out, I'm going to go down. I'm going to look for the 3. It's equal to, so I know it's going to be a closed dot. And then we're talking about all the numbers greater than or equal to 3. So all the numbers that happen to be above as well. What about 2x is less than 12? Well, 2x is less than 12. You just have to divide by 2. When you divide both sides by 2, the 2's will cancel out, and you're left with it. X will be less than 6. Since it's less than and not less than or equal to or greater than or equal to, we can say that it's going to be an open circle, and it's going to always go to the left for less than. It's going to be showing that the numbers are going down. Now graph the solution set, then write the solution as a compound inequality. So what this question is really asking is, can we combine both of these? Can we make a compound inequality between both of what we now know? So I'm going to start at 3, and I'm going to say that we are including 3, and we're going upwards. But we're going to be stopping at the 6, but more importantly, it's a hole on the 6. So we're going to get as close as we possibly can to that 6, but we're never actually going to end up touching it. So there is going to be a line from that 3 connecting to the 6. However, we're never going to include the 6 like we included the 3. All right. So how do you write the inequality? It looks like we're going to be talking about all the numbers between something. So I know that the x is going to be between whatever this compound inequality will end up being. The 3 is the lowest number, so I'm going to put the 3 at the lowest or the left-hand side. The 6 is the highest number, so I'm going to put the 6 in the higher-hand side or the right-hand side. And now I have to figure out the signs. When you're talking about all the numbers in between, we're going to be using a less than sign because that will show the numbers between 3 and all the way up to 6. Now again, we still need to pay attention to this portion right here, the fact that this is an equal to portion as well. Since this is equal to, we know that the 3 has to be less than or equal to the x, whereas the 6 is not equal to, so we can actually keep it the way it is. So this, now the brand new compound inequality that we just created will become 3 is less than or equal to x, which is less than 6. What is the solution of 7w plus 3 is greater than 11, or 4w minus 1 is less than negative 13? And then graph the solution. Cross out the inequality that is not a solution to either 7w plus 3, which is greater than 11, or 4w plus 1, which is less than negative 13. Well, if I were to solve it out, I'm going to do minus 3, and now you're looking at 7w is greater than 8. Divide both sides by 7. You'll get w is greater than 8 over 7. That's the first one. The next one, add 1 plus 1, and you will get 4w is going to be less than a negative 12. Divide both sides by 4. And you'll get w is less than a negative 3. Now notice, you're not dividing by a negative, which means you do not have to worry about flipping the signs. So this will be w is still going to be less than the negative 3. So cross out the inequality that is not a solution. I'm going to tell you that 8 over 7 is the same exact thing. So 8 over 7 equals the 1 and 1/7. They are both the same, therefore the w is less than negative 3 is correct. The w is greater than 1 and 1/7, which is what we have right here, which is also correct. So the one that is not a solution will be w is greater than 1. So we cross that one out. All right. Graph the solution. W has to be greater than 1 and 1/7. So w has to be greater than, so I'm going to put a circle on the number line. That it happens to be greater than 1, but it's going to be like 1 and 1/7-ish. Again, it's going to have to be close. It doesn't have to be accurate 100%, but it has to be close. And if I'm representing greater than, I'm talking about all the numbers above it. I'm also then going to say w is less than negative 3. And if it's less than, that means that I'm going to do an open circle once more. And we're going to be talking about all the numbers that happen to be less than that negative 3. So then the solution to this problem is actually all real numbers that happen to be less than negative 3, but it can be also all the real numbers that happen to be greater than 1 and 1/7, or 8/7. Me personally, I prefer 8/7. But both of those are correct. If the number is anywhere in between, if it's anywhere in the area that I'm shading right now, it is not a solution. Therefore, it will not work. You can plug it in all you want, but the answers will not make sense. And look it, we finally made it to the lesson check. This is the home stretch, guys. We're basically done. So let's buckle down and let's get through this nice and quick. All right? Make up an example to help explain why you must reverse the inequality symbol when you multiply or divide by a negative number. First things first, write T for true or F for false. Is 5 greater than negative 4? Absolutely, that's true. Well, if I were to move that negative sign to the other side, I would have to multiply by a negative or divide by a negative 1. In this case, they decided to use multiplication of a negative 1. So if you were to multiply it, you would get a negative 5 is greater than a positive 4. That doesn't make any sense. So that's going to be a false statement. And the same thing goes with if you do 5 divided by negative 1, that would be a negative 5. And negative 5 has to be less than the negative 4 divided by negative 1, which happens to be 4. And since it is less than, because it flipped the sign, we now know that this is in fact true. So can you explain what you need to do when you multiply or divide an inequality by a negative number? I mean, as simple as it put, in order for the inequality still to be true after multiplying both sides by negative 1, you must reverse the inequality symbol. That is a problem that is guaranteed to run rampant through people's homework. Please make sure when you divide by or multiply by a negative 1, it's going to have to flip the sign. Now again, if I have a 3x is less than a -9, and I have to divide out that 3 from both sides, the x will become less than -3. Notice, I did not divide by a negative, I did not multiply by a negative, and therefore I don't have to reverse the inequality. If it's from that number, if you're dividing from, if you're multiplying from that number, then you keep it the way it is. It's strictly if you're multiplying by that negative. And that's it, guys. Everything is complete. Well done. I'm proud of you guys. I hope you have a good one. Stay out of trouble. Don't do anything stupid. And I'll see you in the next one.